Today we're diving into my 10 favorite tips and techniques for Three.js. These are quick and easy code snippets, methods, and tools for your real-time 3D tool belt. So whether you're a seasoned developer or just getting started with Three.js, ready your minds. Let's go. Watch until the end to learn how to integrate Three.js scenes into the background of your website as an interactive element. Okay, for this tip, I want to talk about how to save what you've set up in the screen. We're going to save an image. It's like a frame from our animation. So I've got this simple primitive setup and a nice gradient background. I've got it positioned just the way I want it. And I'm going to add a key listener so that we can interact with our scene via the keyboard. And then fire a save image function, which looks something like this. What it does is it renders the scene. It creates an image, grabs that image, programmatically click the link. And we'll just set up an event listener, window.add event listener key down. And there's the event. I like to call it EVT, not just E, for more clarity. And I'm saying, okay, if that's the S key, then fire this function, the save image function. Let's save that. Come in here, press S. And let's see what that looks like. There you go. We've saved that image. In an upcoming tip, we'll see how to make this an image with a transparent background auto-magically. In this tip, we're going to create an after image effect. This is really a combination tip and technique. I want this object to move around in a circle and leave a trail behind it as it moves. So the first thing I want to do is just change this rotation to animating the rotation property to animating the position property. And that's going to have it move in a circle like this. That happened auto-magically because I had this code already in place. I'd kind of like it to rotate as well. So copy that, undo, and then just paste it below. So now it's both spinning and rotating. That looks better to me. It's a little big, so I'm going to make it a little smaller. Geometry is defined here. You pass in the radius, which will be 0.7, and a detail. Let's leave that at 0. So now it's just a little bit smaller. Okay, to create that after image effect, first thing I want to try is to preserve the drawing buffer. I'm going to do this just within the renderer itself, and I'm going to tell it to not to auto clear like this. Renderer dot auto clear is false, and nothing happens. Am I in the right file? Preserve drawing buffer, auto clear. Is it because I'm using the composer? Hang on. It doesn't work if I'm using the composer. So renderer here. Okay, so just to repeat what I did. Isn't that a cool effect? I told the Three.js renderer not to throw away the drawing buffer each time, preserve the drawing buffer, and then I told it not to auto clear. If I tell it to auto clear, we're back to normal. And that's the effect. The other way to do this, so that I have more control over the look of the trail it leaves, is to get rid of this. And we're back to here. And then I'm going to use these post-processing effects. Yeah, okay. Those I've instantiated here. I've got an effects composer. I'm going to put that at the top. I think it makes more sense there. And then I create a render scene, which you could just think of as the regular render, plus this after image pass. And then I add both those passes to the composer, and then composer.render. And then you get this after effect. And the sprites become brighter, so I'm just going to dim those down a little bit. Isn't that cool? It's a much shorter trail, and I can control the length of that trail. I can make it a little bit longer by changing this damp value, or a lot longer. How cool is that? Cool, so that's how to leave an after image. Okay, this next tip is a quick one. It's to use the teapot geometry that comes with the examples. In addition, there's also a rounded box geometry, which is kind of cool. I'm just gonna const geometry equals new teapot geometry. Is it gonna hit? It's not gonna tell me what these properties are. It's sort of a drag. In order to look these up, I have to go all the way to where I've got all the Three.js files, examples, JSM, geometries, and then there's the teapot geometry. So I can see size, segments, bottom, lid, body, fit lid, and blend equals true. That's what those properties are. I'll just copy these. Close that up, and then add that here for reference. Those are the defaults. Yeah, and if I save, now I've got a teapot. How cool is that? Yeah, it's just a fun thing you can do. And there's a weird render glitch where I can see inside of the spout. To fix that, just change this to side is 3 double side. Now the spout renders properly. So there you go, teapot. In this next tip, we're going to use the scene.override material property to apply a material to every object in the scene. I've got this teapot right here. I actually want it to be a little more chunky. So I'm going to reduce that. And while I'm at it, I kind of want that to be faceted. So let's say flat shading is equal to true. And now I can see the different facets on that. It's like an old school low poly thing. But because of the hemisphere light, it has this nice gradient on it. Anyhow, getting sidetracked. Let's add another object to the scene, and let's add another object to the scene. And then come up here, add this line, override material equals a new material. In this case, I've a mesh basic material that's green and has a wireframe true property. Save that, boom. Every object in the scene has a wireframe on it, and the sprites I had in the background disappeared. That's interesting too. So I can comment those out. Same diff. Yeah. This technique is about adding glow to your scene. There are 3 steps in implementing bloom or glow, and that is get the imports, then instantiate, right here above the geometry and below the controls. This is just the vanilla render, the thing you see on the screen now. That's the render pass, render scene. I don't mind calling it a pass. I just think that's more clear. Then we'll do this bloom pass, and we pass in the resolution, the strength, the radius, and the threshold. We create a new effects composer, and we add our render pass and our bloom pass to that effects composer. Come down to the animate method where we call our renderer and replace that with composer. And oh my god. Let's really dim down the sprites so those aren't contributing that much. And there you see that pretty glow. Bloom pass dot strength. I want to try something weird. Bloom pass dot strength. Can I say strength like that? Oh, that works. See how the glow is kind of coming on and off? Oh, that's cool. Well, that was a fun experiment. Let's get rid of that. Now our bloom pass is just static. The strength, rather. Let's dial it down to 1.5. Still got a nice glow. And just so you can see what it looks like without and with. Isn't that cool? Yes, it's cool. Let's see what it looks like with a wireframe material. Actually, not that remarkable. If we make that wireframe a basic material, so it has uniform color throughout, now we probably want to crank it up some more again to get that glowy effect. Heck, go all out. I'm going to kill those background sprites so we can just focus on this guy. Yeah. Let's see it with and without the glow. Without the glow and with the glow. Yeah, so that's pretty great stuff. Add fog to your scene. Here's how that's done. Scene dot fog equals new 3.fog. I like the exp too. Now there's a regular fog and this exp exponential fog, which is I think it's more physically accurate. We're going to give it a color and I think a density. Okay, so 0.1. And that's how that works. See how it fades away? If I gave it a denser like that, oh, that's pretty dense. It's totally darkened out the sprites, and it's added a lot of darkness to this guy. Let's see, 0.3 might be better. Yeah. You can give the fog different colors, and you can tell objects to ignore the fog on a one-off basis. Let's do that real quick. First, I want to do it to the sprites. I'm going to modify the API for my sprites to pass in a fog property. Let's call it false, actually. And I like has fog. I think that's more clear than just fog. Now, this is a shared resource in my setup, so I gotta go find that inside of libs. Excuse me. I put it here, get layer, and I'm gonna pass in a new property here called has fog, and it defaults to true. And now I'll find the material I'm using here. I gotta pass it in here too. Has fog. So each sprite has its own sprite material. Let's put it here. Has fog. The nice thing about using an object as a params object for a function argument is that the order doesn't matter. Isn't that nice? If I pass these as individual args, kind of like this, the order would matter. But it doesn't matter this way. Because it's just an object with properties, and you can find that property. It doesn't need an order. The sprite material hopefully has a fog property. Let's see if it does. Fog has fog. And it does! That's so cool! Just to recap what I just did. I rewrote my reusable getLayer method. It just gets these background sprites, so the scene looks more interesting. To add a has fog property, I gave it a default value of true, so that if I don't pass anything, it automatically uses fog. But if I do say, hey, don't pay any attention to that fog, it will ignore it. Let's, as a last fun activity, let's pass in. I'm going to estimate the color of that the background sprites, BB, to kind of give the fog. It's too bright, but I really like the look of that. And that's not even close. How about 9.9? So the bluish fog, it kind of looks like it just freezes. But yeah, you get the idea. If I just make it black, like that, then it turns black. It looks like a spotlight or something on there. Anyway, that's one way to use fog. in this tip, I want to make the background of my Three.js scene transparent so that the HTML defined background comes through. This will be useful when we want to save an image with a transparent background, or if you just want to have the background of your HTML page. Right now I've got a linear gradient defined for my background in my scene. Right, here it is. So I've got this linear gradient. I'll get rid of that and just make it black, like so, or white, like that. Yeah, that's really all there is to that. Oh, I guess I should tell you how to do it. This property here, alpha true, is the money property. If I get rid of that, the background is no longer transparent. So this technique is a fun one. We're going to add an outline to our object. This is a icosahedron mesh, and the way we do it is to create a special material, const outline material, and it's going to be a new 3D mesh basic material. I'll make it black, and this is where the magic happens. Side 3.backside. I'll explain it by finishing up. Const outline mesh equals new 3.mesh, and now set the scale. This isn't quite right. Let's fix that. Set scalar like that, 1.05. Yeah, that's fine. And now mesh dot add outline mesh. I added to the outline, I added to the mesh, not to the scene, because I want it to pick up all the transforms of that mesh. And I'm rotating the mesh in the animation method, so now the outline mesh gets rotated automatically too. So this 3.backside, what's that all about? If I copy that out, now we just have a black object. But with that on, I'm telling the renderer, hey, every time you see a face, look right through it until you see a back face. Okay? And in this case, those are inside of that slightly larger icosahedron. And the net result is that you just see the border part. Isn't that cool? Let's see how this looks with a teapot, which is slightly more complicated geometry, and you'll see there's some issues. Not huge issues, but issues anyway. Let's say const geometry is a new teapot and make it kind of small. Maybe 1 is good. All right. Now, because it's a more complex material, there's a few issues. The border doesn't work properly inside of the handle, and it's missing from the top there. But it still kind of looks cool, I think. It looks even cooler as a tighter outline. It looks more like a toon outline. So for this technique, I'm going to use the Three.js canvas as a background element in my scene. Typically, when I'm working with Three.js, I let Three.js create the canvas element that this will all be rendered in, and then add it to the DOM. That line is document out here. I instantiate the renderer, and then I use its DOM element as the canvas. That is a canvas. So instead of this, I'm going to delete that. Now it doesn't get added to the scene, but I'm going to add it myself. Right now the body of my scene has just the script, but I'll just grab this bit of code here and paste that in here. And what we have here, it's not formatted properly, is a container, a div that holds everything, or will hold everything, and then the canvas, and a bunch of dummy content. And if I save it, it's still broken. I look at the JavaScript console, there's no error, because I'm just not adding the renderer. What I need to do is const, I'm going to grab that canvas element equals document dot get element by ID, and I'm calling this 3 canvas, like that. And then I'll pass this into the renderer, canvas, is canvas L, like that. And now it knows how to render that. Isn't that wonderful? Not quite done yet though, because I need to grab all of the CSS rules, which aren't defined yet. I've got this stuff in here, but Three doesn't know how to handle that. And you can't even see it. I don't know why you can't see it. I think it's because I can't scroll to it because of the orbit controls or something. I'm not sure, but let's just grab those CSS rules. Here they are. I'll just grab the entire style element, and I'll go over these in a sec. And then in my scene, canvas as background. That's the name of this one. Now I've got these elements here. Let's just go over the CSS real quick. I've got a variable that defines a 20 EM gap, and I'm using that here at the margin bottom for these reusable elements, the content panel and hero panel. Content panel and hero panel. That's pretty much it. This is a tutorial about Three.js, not about CSS, but just to let you know. Yeah, that's how you do that. Isn't that cool? In my last tip, I made the Three.js canvas a background element in my HTML scene. Isn't that cool? This time I want the Three.js scene to respond to scroll events. As I'm scrolling through the page, I want this scene to update. So to get started with this one, I'm going to stop the animation. Okay, just by deleting that. And I'm going to add a listener to the scroll event. Let's say window.add event listener. Not key down, but scroll. And when the scroll happens, that's not what I want to do. I'm going to update this a property that I'm going to create. Scroll pause y equals window.scroll y divided by the window inner height, and then some multiplier. I'm going to define that mult inside the method just to keep it clean. Const mult equals 6, and we can adjust that in a sec. Let's also declare this as a kind of global variable up here right below the controls. Let's say let scroll pause y equals 0. Good. I broke it. Let's see how I broke it. There's a missing after the argument list on line 65. Here. Oh, I apologize. So nothing's happening. Let's just debug this real quick. Console.log scroll pause y. Thank you. And let's open the console. And as I scroll, see this value changing? So the max value is just below 31, and the min value is 0. So that's what mult gives you. Well, let's show you before I tell you. And get rid of this thing. I really only have a mesh in the scene. Ideally, there'd be other things in the scene, and I would update the entire group of objects. But in this case, it's a simple case. I'm just going to say mesh.rotation.x equals scroll pause y. It's pretty rough and dirty, but as you see, as I'm scrolling now, it's kind of turning the opposite direction. Let's make it negative scroll pause y, so they seem to go in the same direction like a gear. Isn't that cool? I think so. Position.x equals math.cosine negative scroll pause y times a radius, which will be 2, and we'll make that y, and sin Let's see what that looks like. Kind of weird. But you get the idea. You can apply any kind of transforms you want. I'm going to undo these because I don't like them. To your scene. Whether it's just a single object or a bunch of objects in your scene. Whoops. Let's redo that. Yeah. And if I change the mult down to something smaller, that should rotate a lot less. See it rotating barely? It's still cool. It's also contrary. I can put the multiplier in here, the signage, I mean. Isn't that cool? There it is. Consider leaving a comment below if you've got some advice, some criticisms, or a suggestion for something you'd like to see created. Here's a comment I got recently from Keith Price, 1950. He said, "Great tutorial, thank you. I've just started working with Three.js, and I don't think the docs are very easy to follow, so this helped out a lot." Well, thank you, Keith Price, 1950. And thanks to all of you. If you have the means, please consider supporting me over on Patreon so I can continue to make these videos, which I love to make. Thanks again, and I'll see you soon. Bye.